So as we are looking at today's lesson, we are looking at logarithmic functions and their graphs. So first and foremost, we need to figure out what in the world is a logarithmic function. So a logarithmic function is just the inverse function of an exponential function. Okay, so if you recall our inverses, we flip the x and y's and then solve for y, or you could think about your table, your x and y column in your table has been completely flipped. So as you are looking at your exponential functions, the functions that we've been talking about most recently, that's f of x equals b to the x power. The logarithmic function is its inverse, and so the inverse would be log base b of x. Now notice that b is kind of in that subscript, it's kind of offset a little bit. So here's the key. We are going to be looking at today, how do you change between logarithmic and exponential form? So logarithmic and exponential form. What I typically do is, if it is like y equals log base b of x, I typically write it the other way. I do log base b of x equals y, and then I kind of go around in a circle. So what I mean by that is I'm going to take my b is my base of my log, it is also the base of my exponent. So b to the y equals, and then I'm going to go around to finish that circle, equals x. So we have on the right, we have an exponential form, and on the left, we have a logarithmic form. Okay, obviously to go the other way, we would need to undo that process. So as you look at this, we have several different sections of properties. So if you look, the basic properties of logarithms, because we know b to the 0, anything to the 0 is 1, if you undo it, so if we take a look at this, your base is still b, and then we're going to go around in a circle. So b to the 0 equals 1. And so that makes sense that anytime you have log of any base of 1, that's going to equal 0. Again, that's because if I were to rewrite this, a lot of times this is my thought process, log base 6 of 1, I let that be whatever, and then I solve. So that becomes 6 to the x power equals 1, and so I ask myself, what is that power? Pardon that interruption. I have to ask myself, what does that power have to be so that my exponential will be equal to 1? So again, if I think about my next one, I'm going to let this equal x, and I'm going to say 3 to the x power equals 81. So again, I'm going to slide this under, it becomes the base, go all the way around. And so then I have to think about 81 is 3 times 3 times 3, how many times? So 81 is 3 times 3 times 3 times 3, so you have 4 of them. So that answer is going to be 4. If we look at the last one gets a little ugly. So if we look at this, we're going to set it up equal to x, so then we can rewrite this to be 6 to the x power equals 1 over the 5th root of 36. Now for some of us, that's like, what's just happened? That looks really ugly. And so what we would need to do is we would need to take this apart a little bit. And so the 5th root is the same as the 1/5 power, so I would rewrite it like that. And then if we take a look at this, in order to get 36 as the same base as 6, 36 is 6 squared. So I would rewrite that 36 to be 6 squared. Everything else stays the same at this point. So I've got the 1/5 power, all of that is under 1. I can multiply my exponents, so that becomes 2/5. So I have 1 over 6 to the 2/5, and then I have to recognize, because that's on the bottom of my fraction, it is actually a negative 2/5. So let me kind of recap that. Because it's the 5th root, it's a 1/5 power, then we have to have matching bases. So we have to rewrite 36 as a base of 6 to match, and then we can multiply those exponents, get it out of the bottom by making it a negative. So again, that one's a little bit ugly, but hopefully that makes sense. If we look at the next one, please let this just be kind of natural. Notice here it says evaluate without a calculator, but notice you don't have any bases written in here with these logarithms. That's because anytime it is just written as a log of anything, so of any number, if there is no base there, it's an understood base of 10. That's what it means by common logarithms. It's a base 10. So if we think about this first one, again, we can go ahead and set this equal to x. It's an understood base 10. So 10 to the x power equals 1 over the square root of 1,000. So as we look at this, again, very similar to that last example on the previous page, we need to figure out this 1,000 as a base 10. So we can kind of do it in several steps. Since it is a square root, that's the same as a 1/2 power. Because 1,000 is 10 to the third power, I can rewrite that as 10 to the third in parentheses, 1/2 out in front, or excuse me, out at the back end. 3 times 1/2 is 3/2. And then because it's in the bottom of the fraction, it's going to become a negative. So it becomes a negative 3/2. Okay? The next one is hopefully even easier. So if we take, notice this is now written as an exponential as opposed to a base, or excuse me, as a logarithm. So if we take this kind of apart, or if we think about it kind of being undone, this is becoming log base 10 of x equals log base 10 of 6. So in other words, I undid it, because now if I were to work the other way, that becomes 10 to the log of 6 equals x. So I just went back to this original by what I did in the red. So I basically undid the exponential. Now if I look, these two have to match, therefore x has to equal 6. Okay? And that is an example specifically of this property here at the end. The other type of logarithm that we see is a natural log. So anytime you see this ln, ln is the same idea as log base e. It is a logarithm with base e. So here's what I don't want you to do. I don't want you to overthink this. So if you look at the natural log of e, those are inverses of each other. So those just kind of cancel each other out, so you're left with -4. Now you could have thought about this last one that we did, kind of the same concept. That if we look at the last one, a exponent of 10, excuse me, a base of 10 and a logarithm, those are inverses. So 10 as a base and a logarithm, those are inverses, and those cancel each other out, so you're left with 6. So if you take a look at the natural log of 1, we're going back to this original power, or this original property. And so again, my thought process, if I get confused, is I have log base e of 1, that's what a natural log is, set that equal to x. And if I'm going to rewrite this, it becomes e to the what power equals 1. And that's going to be 0. Anything to a 0 power is 1. And then I can go ahead and do the same thing for this last one, that this is going to be log base e 1 over the square root of e to the 7th. And so if I let this equal x, I can rewrite it to become e to the x power equals 1 over the square root of e to the 7th. And so now I just need to manipulate this right-hand side. So again, I have e to the 7th power. Since it's a square root, that's really to the 1/7, or excuse me, 1/2. And then I can go ahead and multiply my 7 and 1/2 to give me e to the 7/2 on the bottom. But again, since that's in the bottom, it's actually a negative exponent, so it becomes negative 7/2. Okay, so that's kind of the basis of logarithms. Anytime you have a logarithm, common log, or natural log, just remember those are inverse functions of exponential functions. So that's the basics. We're going to go ahead and stop this video for now. I'm going to record another one with the back part of these notes for the second day dealing with the graphs.